Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to Ask Engineer. It's me, Lady Ada, with me, Mr. Lady Ada, on camera control behind the camera. We're here for Ask Engineer, broadcasting live from downtown Manhattan in the secret Adafruit headquarters, slightly off of Adafruit main
Sort
headquarters.
of.
We've got a fun show for you tonight with all sorts of products and codes and tutorials and videos and more, including some amazing guides and videos. Why don't you take it away, Mr. Lady Ada, and tell them what's on tonight's show?
On tonight's show, the code is ATtiny. It's 10% off the native free store all the way up till 11:59 p.m. or when I put our kid to sleep. We will have a bunch of free stuff we'll talk about in a second that you can get as you add things to cart, but this is 10% off anything in stock all the way up until probably midnight-ish. We're going to talk about some of our live shows, including Show and Tell, which we just did a few moments ago. Talk about from the desk of Lady Ada, JP's product pick of the week, and a little bit of a preview of what's going on JP's show this week. From the mailbag, some advanced manufacturing made right here in New York City. We got some 3D printing, some top secret, some new products. We answer your questions. We do that over on Discord, adafruit.it/Discord or discord.gg/Adafruit. That gets you over to Discord. That's where we answer all the questions. All that and more on, you guessed it, Ask an Engineer. Okay, so first up, Lady Ada, I mentioned that code, ATtiny's.
ATtiny's.
ATtiny's. ATtiny. We have free stuff.
That's right. We have freebies. $99 or more, you get a half-sized permaproto breadboard. People love this because it's great for taking your breadboard projects and making them permanent.
Yeah.
I designed this for myself, but you can use it too. 149 or more, we've got the KB2040. It's an RP2040 board with 4 megabytes of flash, a super speedy 130 megahertz Cortex M0 processor, Pro Micro GPIO layout, USB-C, STEMMA QT, buttons, and a little NeoPixel. It's great for all sorts of microcontroller projects. We've got a ton of RP2040 code you can run on this in Arduino or CircuitPython. $199 or more, you get free UPS ground shipping in the continental United States, and $299 or more, you get a Microbit V2. These are back in stock. We want to celebrate. The Microbit V2 works with MakeCode, and you can also run MicroPython and CircuitPython on it. This Cortex ARM M4, this is an NRF52840, is really powerful. It has all these cool sensors on it, and there's thousands of tutorials from school kids around the world.
Now, usually after I do the code and we talk about the free stuff, I say, hey, don't forget to have two-factor authentication on your account. There's been a part shortage. There's still some things out there in the world that are hard to get. But we have order screening to make sure people aren't buying stuff and then reselling it on like eBay for like $500. People are trying to do that with Raspberry Pis. And then there's also stuff that was just supply constrained, and we wanted to make sure we had a chance for everyone to purchase something. So a little bit of a story. This is kind of fun.
Time, Benny.
I will start at the end of the story and then I'll go to the beginning. So now Adafruit is Better Business Bureau accredited. There is a criteria that you have to hit. They have to agree that you're taking care of customers and you're resolving any issues, that you're sending goods and services, whatever it is. But let me start at the beginning. So the way it works is sometimes when we ban the people who are using bots or they're trying to get extra Raspberry Pi so they can sell for like $300 or $400 and really get these away from school kids and anyone who really needs them, who wants to just purchase one. So we ban them and they get very upset, like really upset. And they'll call our staff names. There's been all sorts of like the threats and everything. So one of the things they do is they open up a Better Business Bureau complaint. And they say it's not fair. I should be able to buy I should be able to buy as many Raspberry Pis as I want and sell them on eBay for $500 because that's what I want to do. And I don't like that after I called Kelly a name at Adafruit, I got banned. Because we try to work with people and say, hey, you're up here, we need you down here.
And they're not calling her Kelly the Clown, by the way. It's much worse than that.
Yeah, so or like any of our team or me, or they'll leave a nasty voicemail on our phone. So what happens is each time there's a complaint, we're not taking any form of money from the person. The Better Business Bureau is like, hey, you got this complaint. You probably don't need to do anything, but here's what it is. So we answer every single one of them. So eventually, after you answer enough of these, they're just like, hey, you do a really good job with answering anything that comes up. We don't see any issues that in fact you're handling some supply chain issues pretty well. Then they can you get entered to be accredited according to their system. You just have to fill out things, prove you're in your business and all that stuff. So now we get to put this thing on our site, and we can say we're accredited and we'll still handle this stuff. But it's funny, this is a little bit, we had a maker business segment that we would do once in a while. It's a little bit of a judo move, because the intention for these folks were to damage our business and leave like nasty reviews and be mean. But it turns out this is actually something in our favor, because it just showed that we take care of all these things in a fair way, and more people got Raspberry Pis. The people that were trying to resell these for hundreds of dollars and or use bots and stuff like that, they're not getting them. A little upset, but here it is. So, anyways, someone said in the chat, the trolls helped us get BBB accredited. And this is kind of an old school thing. It's like when you walk in the stores and you see like the sticker, it's like, okay, they're legit. So that's our story. And so thanks everyone for doing two-factor authentication, and I guess thanks to the meanies.
Yeah.
Yeah. All
And
right.
by the way, if you complain to the BBB, it doesn't make up for your behavior.
Yeah. All right, so we have a bunch of live shows that we do every single week. We just finished up the show and tell.
Yes.
There's favorites that we pick.
They're all
Sort
our
of.
favorites,
Yeah.
but there's some that shine.
Yeah. So check out the staff projects. Really neat cat keyboard that JP was doing. Phil Beef found this really awesome, amazing retro 80s boombox cassette player thing. Pedro has the start of a project for there's a Tron ride that's opening up. Pedro is right near Disney, so you'll probably see some footage from the actual ride, and then also this memory disc, data disc thing. And then one of the projects, there was a really neat costume.
Yeah, it was like a cosplay fursuit head, but had these LEDs, and it was so
Really
cool.
neat. So that was from Flying Things.
A beautiful build.
And then Mouse showed up with some really neat synth stuff. So all of them are our favorites. But this was a really neat musical cat night, if that's your thing. Oh, and Liz showed up with the
OctoPrint, which
Yeah.
is this week's 3D
Yeah.
print. Well, really, I feel like people are starting to do stuff again. People are building projects. You can get parts.
Yeah.
It's like the it's not that just a shortage, but the culture of like shortages. It's like, I want to use this thing because what if I can't get another one? Now it's kind of nice. People are starting to feel free to
People are
build stuff.
peeling off the screens of their the plastic off the LCDs because they can get new ones and more of them. Okay, on Sunday we do From the Desk of Lady Ada. We do this in two parts. So part one, what did you show off this week?
Okay, this week I finally finished and ordered PCBs for the Ada logger. I got, it's just like getting it's like that last 10% takes 90% of the time. I spent like a whole day just tweaking silkscreen and the manufacturability. I'm going to make a tester for it and everything. And then I also made a little bit of progress on building a minimum viable player for the Baby Einstein player. I don't know if you're going to show the other video.
Yeah, we have the Great Search, and then you were looking for a part, and then we're going to talk about
Okay.
the My Little Hacker series. But you also showed folks where they can get the parts for some of this.
Yes, so the connector that I used on there is the Pico blade, and I thought it'd be really handy to show people. First off, you can get the connectors, which are much slimmer than JST-PH and a lot higher current than JST-SH. The blade is what does the job, lets you get like an amp out of these connectors, which makes them perfect for speakers. Also batteries, they're good for batteries as well. Not as good for you can use them for data, but I use JST-SHs for data, and then again these Pico blades for power and speaker. And you can also get cable assemblies from DigiKey as well. Don't forget that. So don't, if you have to crimp, crimp. But if you don't have to be crimping, don't crimp.
All right. And then we have sort of a new series of videos that we're doing. It's My Little Hacker, and it's when we take apart our kids' toys and change them and make them better and put all the things into them, or take things out that parents say, boy, I wish I could change the volume. I wish I could change the songs because they're really repetitive. So you have more progress that you made on the on the
Yeah.
project. This is the Baby Einstein take along tunes. What did you do this week?
So this week, well, first off, I was like laying out the board and I kind of picked all the parts and I realized I should probably verify that they work before I start laying out the board. So I grabbed a QT Py ESP32S2 and I made a I2S amplifier BFF so I sound it on the back. Um, and we loaded up some WAV files, including you got of somebody who recorded the original audio, and
Yeah.
then we put that back on so it could like play it. And we're using the speaker. And I realized that you can't run off of the 2AA batteries, so I needed a boost converter. So I got that installed on there as well. But it sounds really good, nice and loud. And then I loaded up some CircuitPython code because I wanted this to all run in CircuitPython so people could hack and mod it. And we use the audio mixer to change the volume. So that's really handy. So you can dynamically change the volume and through I2S. So it sounds really good. The speaker
Yeah.
and amplifier sound,
Right now,
it's
the
really high
first
quality.
kids toy that plays Nine Inch Nail songs.
That's right.
Like pretty soon too.
Pretty soon. And the next thing I'm going to test is whether it can stream audio off of a micro SD card. So I've got those micro SD BFFs. I'm going to put that on, verify that works, and then I'm going to go back to laying out that PCB.
Every single Tuesday we do JP's product pick of the week, where we broadcast live from the product pages of Adafruit. The discounts are automatically applied. Here is this week's highlight. Oops.
It is the 16 by 9 CharliePlex PWM LED driver board and the 16 by 9 LED boards themselves that you can pick one of to pair up nicely with your board. These allow you to easily now with StemmaQT connect up to your microcontroller and send very easy pixel commands and brightness commands to decide which of these kind of pixels you're lighting up. These are single color LEDs, as well as their brightness on an individual level, so you can do some really nice gradient effects. Here you can see I have just a little, pretty simple, I'll show you the code in a second, pretty simple code that is sending some a little heart pattern, and as it builds that pattern, it's doing some PWM brightness things, so you can see it kind of fade vertically. And then I'm wiping across horizontally, again, with altering that brightness level as I go. This is through a little bit of diffusion acrylic. It is the CharliePlex 16 by 9 PWM LED driver board with StemmaQT.
All right, and tune in tomorrow, Thursday, 4 p.m. Eastern Time for JP's workshop. He's showing off some cat pianoing and more, and then deep dive with Tim on Fridays at 5 p.m. Eastern, 2 p.m. Pacific, where you can learn about all the innards of CircuitPython and more. This is a really good series, especially if you want to see kind of step by step of working through a lot of the code and libraries that we put into CircuitPython.
Letters, we get letters, we get tweets, and we get emails.
All right, mailbag this week. We've got it's always nice to see a nice tweet. You can use Twitter for nice things. This was from a teacher. Fourth and fifth graders are making magic wands with Adafruit Circuit Playground. It's a mix of computer science, art, and creative fun. Thanks to the amazing and that's a teacher, Robin, for making this happen. And here's some kiddos learning computer science and art and electronics.
It's so great to see kids back in school
Yeah, like this.
and doing stuff together and like these kinds of things. I know that people are trying to do some of the stuff remote, but it's really hard. You need to really
It's tough.
debug with people and people be able to look at your
But
screen. So
before
this is
and I
cool. And
think
this is like the first classroom photo I think we've
it's been a
done
while.
in like a long
It's been
time.
a while, and they had to make sure it was okay to take a photo of the
Yeah.
kids and stuff. So, anyways, thanks for getting the word out of this. A lot of classrooms use Circuit Playground. We built it after we met with some New York City teachers, and we wanted to make something low cost. Work with Chromebooks, showed up as a USB drive. Can use Python, can use MakeCode, can do Arduino. You name it, it can do it, and it's getting out there. And the Magic Wand project's pretty good to start off with. Blink, Python on hardware time. Okay, so this week, let's go right to the newsletter. Version 150 has been released of the official C++ Raspberry Pi Pico software development kit.
Yes.
This is Bluetooth related. So why is this a big deal? Because people want to know your opinion about these things.
That's right. Well, the Pico W, which is an RP2040 chip that comes with this Cypress like 43439 chip or something part number. And that module can do Wi-Fi, and we've added Wi-Fi support to CircuitPython. There's Wi-Fi now in the SDK and Arduino, MicroPython, CircuitPython, which is great. And people are like, hey, this chip can also do Bluetooth Classic and Bluetooth Low Energy. And they're like, yeah, it's coming, it's coming. So, so the Raspberry Pi team finally picked a stack and implemented C++ SDK low-level support for the chip. They're using a stack that is not open software, but they do have a license. So much like Wi-Fi, it's licensed as long as you're using it with an RP2040 chip. So although I don't count me on that for the Bluetooth. I know for Wi-Fi it is Bluetooth. I don't know if they released an official license yet. And I saw there's a pull request for MicroPython as well. And then I saw Pimoroni did a little demo where it acts as an A2DP endpoint, which is actually interesting because it's Bluetooth Classic, not Bluetooth Low Energy. So we have to dig in to see, what is the support? When is it going to come to CircuitPython? I really don't know.
Yeah, this is all super new.
This is really, really new. We have to investigate it. And another thing is we already have Bluetooth support, and we would want to have it be like cross compatible. So like all the Nordic stuff that you would do, I want to make sure that as much as possible you can do the same things, but we're also pretty much going to be not stuck, but we'll have to use the stack that they've used to make it work, because porting our own stack I think is going to be a ton of work. So we don't even know what the scope of the work is yet, but it looks like it's coming to MicroPython soon, which is great. We love supporting MicroPython, and I hope to also have it come to MicroPython.
And someone mentioned this in the chat, and that was a surprising thing. So it can do Bluetooth Classic?
A2DP is classic, not I mean, unless I misunderstood the demo. I believe that it's using the Bluetooth Classic.
Yeah, so we're gonna double check this and look at it because that's kind of cool if it's true.
Yes, HID Classic is more common for like keyboards, so I think that could be very powerful. And also, Classic Bluetooth tends to use a standard transport called HCI. Well, we'll see. I don't know yet. We haven't even again. This is like days old, not even
hours. And then. Before I go to the project I wanted you to talk about, a lot of things have been going on in the world of open source, Python, CircuitPython, MicroPython, but wanted to call attention to KiCad 7.0 release is out. There's some neat stuff that you can do with fonts now.
I said that, this is separate. This is the Unicode converter, which I found on GitHub, cool, and I just think it's hilarious.
And then check out the rest of the newsletter because there's too much to go over in our Ask Engineer show, which we're doing right now each week. But it's chock full of everything. Anne's doing a fantastic job with it. Liz is interviewed. There's talks from some events with Python on hardware. There's some really neat Python resources, whether you're doing desktop Python or web Python or embedded Python. But the project of the week out of the newsletter that you found that you were looking at is this really neat computer. It's a complete computer running MicroPython.
Yeah, this is from Brian Whitman, who's awesome. I mean, I don't know if you remember, we met him. He's in New York, and he's done a lot of cool audio stuff. He sold a company to Spotify that does audio classifications, and he's always been doing like really cool hardware stuff and audio stuff. I think we met him at Dorkbot, which I don't even know if it's Dorkbot.
Dorkbot is a mailing list. I don't know if it's a physical event.
I don't think it's a physical event. People should bring this back. Dorkbots were really cool.
Yeah.
And so he built this computer based on the ESP32S3. I think it's an 8 megabyte flash or 16 megabyte flash, 8 megabytes PS RAM. So it's like a maxed out module. And the S3 has this ability to drive a TTL display. So you don't get a lot of colors. I think you get 16-bit color, maybe 8-bit color, 12-bit color. But it's good enough for this. And I like that he just sort of made it into like an all-in-one computer using the USB host capability of ATtiny USB to have it connected to a keyboard. Can run from battery, and it's just like it's an adorable little, kind of Commodore 64/Z80/
distraction free.
Yeah, it's like an all-in-one little mini computer, and I just think he did a really cute job with it. So check it out. The files are all public and posted, and it has a lot of audio interfaces because, of course, Brian Whitman loves audio stuff.
CircuitPython newsletter delivered every single week to your inbox. We do not spam. We do not harvest your email. You have to go to a completely separate site because we want to have nothing to do with your Adafruit store account. Go to adafruitdaily.com and you can get this delivered, or you can read on the web. Totally cool. Either way, up to you. All right, we're an open source hardware company. Speaking of all this open source stuff, Lady Ada, to prove it, we post up code, we post up files, we post up tutorials, we post up everything you need to do all the stuff that you want to do. What's on the big board this week?
Okay, well, we got a bunch of new product guides. Okay, so the LED rocket lamp. So the OctoPrint controller monitor, I think, is this week. So Liz
We'll be showing a video.
and Noah, yeah, they did a video. It's just a great demo for the new reverse mount TFT feather because there's got these buttons and a display. So you can, there's a lot of projects I think people can make without any soldering at all. And this is an MQTT. Basically, it sends MQTT messages to OctoPrint to start, stop projects, get status, turn on the preheat plate, etc. A lot is documented and uses Adafruit IO as a broker.
A lot. This is very comprehensive. This is our learning system, so you can make and remake all of these things.
Okay.
What else?
Next up, piezo buzzers with Whippersnapper. Whippersnappers are no-code IoT platform. If you want to make tones, you can use a piezo buzzer. It's basically PWM output support where you can change the frequency. It's 50% duty cycle. So here's how to do that. We've got an updated guide for the ESP32S3 Feather. It's updated because they now, the chip that I was using for battery monitoring, the LC709203, has been discontinued. And I've swapped it out with the Max 17048. It works a lot better. We've got from Trevor a PyLeap ESP32S2 TFT boxing glove. So Trevor likes to box.
Play this.
Yeah.
After this.
Yes, I asked him to make a video, and he's also the iOS developer. So it's like if you're like, oh man, I hate iOS development, I gotta like punch some stuff to get my aggression out. But you also want to keep track of like how hard you're punching. So using accelerometer to track the strength of your punches, and then sending that data over to Adafruit IO over Wi-Fi. So this is like an all-in-one project that again uses a Feather TFT, which is great for debugging your setup, and also a STEMMA port connects to accelerometer. So again, no soldering required. It's very plug and play. And check out PyLeap, which is the app that he worked on to do drag and drop. To do wireless reprogramming of boards.
Yeah.
I've also got a couple updated guides. I think these all got Whippersnapper updates. Huzzah 32, the Funhouse, and the soil sensor. We have a new guide for the reverse TFT Feather. Thanks to Kenny for writing this. And then Liz did a project guide with this as well. So a good pair. You can use this with Arduino or with CircuitPython. It's got buttons, LEDs. It's perfect for reverse mounting, and comes with my favorite ESP32S2 module with flash and 2 megabytes of PS RAM, which is sweet. Noah and Pedro released a stand for this board. So it goes together with Liz's project. You can see there's a slot in the back so you can plug in your STEMMA-QT connectors or sensors. And then finally, a micro SD BFF guide. This little board allows you to add a micro SD socket to your QT Py or Xiao boards using the SPI port and then one CS pin. Good for data logging, a little like miniature data logger, or if you want to do like audio playback or store images or videos or whatever that you want to display on a TFT. This micro SD BFF is in the bag.
All right, and don't forget to check out learn.adafruit.com. You can look at all the guides and more on our Learn system. Okay, let's play a couple of videos. I'm going to do the OctoPrint and then the boxing video, and then we're going to roll right into some factory footage.
You can use CircuitPython to control and monitor your OctoPrint server. OctoPrint is an open source project that allows you to remotely monitor your 3D printer. This build uses MQTT to communicate with OctoPrint via 2 plugins, with Adafruit IO acting as the broker. The CircuitPython code is running on a reverse TFT ESP32S2 Feather, housed in an octopus-themed enclosure to honor OctoPrint's mascot. The board screen shows the current status of your printer according to OctoPrint. If a print is running, a progress bar will be displayed denoting your print's progress. The display also updates to let you know when a print has finished. There are 3 buttons that can send REST API commands to OctoPrint. If the printer is idle, you can have the hot end preheat, cool down, or you can reboot OctoPrint. While you're printing, you can pause, resume, or cancel a print. See how you can build your own OctoPrint controller by checking out the Learn Guide at learn.adafruit.com.
That's Hunter.
And that's some main New York City factory footage. We're gonna do some 3D printing. 9-page worth 3D printed out bunch of stuff. We got a very cool project and then a speed up as usual, so I'm gonna just let them take it away.
This is the new Feather with a reverse TFT. It's an all-in-one dev board with a built-in display powered by the ESP32 Wi-Fi module. With this Feather, you can choose your flavor of Wi-Fi module. The ESP32 S2 or S3 are espresso chips that are great for making low-power friendly projects. Both types come with native USB, so it's perfect for use with CircuitPython or Arduino. The S2 has a single core and Wi-Fi, while the S3 has dual core processors with Wi-Fi and Bluetooth LE. This feather features 3 buttons, 4 megabytes of flash, Stemma QT, NeoPixel LED, battery monitor, and charging for making portable IoT projects. With so much built in, you can get your projects going without any soldering. The color TFT is an IPS display featuring 240 by 135 pixels, so you get bright colors at any angle. You can 3D print our stand to prop it up on your desk for making Wi-Fi projects with a mini display. The feather is secured to the stand with hardware and allows access to the user buttons and various ports. This OctoPrint project uses Adafruit I/O and MQTT to send and receive commands for controlling your 3D printer running the OctoPrint software. To build this project and get more info on the feather, check out the guides by heading over to learn.adafruit.com. We hope this inspires you to check out the Feather ESP32 with reverse TFT to make your own IoT projects.
Right, before we get over to new products, don't forget the code is ATtinies, and you get a bunch of free stuff when you add it to your cart. You know you want to. Don't forget to save $1 on the way out, lady. It is time. Are you ready?
Yeah.
All right, extended version. Okay, first up.
Okay, we've got an update to the 2.13 tricolor ink display breakouts. It's actually one of our first ink breakouts that we made. It's a very popular size and style because I like the red highlighting that they've got. So this updated version is the same pinout, same size, same shape, same code, everything except on the back. We now have a iSpy connector at the top. So that means that if you would like to connect to this board without having all those wires soldered or header, there's now a solder-free way to do it with the Flex connector. We've been adding iSpy connectors to all of our displays. We got through basically all the TFTs, and now we're going to be doing the e-inks.
Next up,
we've got RFM 69 modules in 900 megahertz and you can see on the back here, different frequencies. And this one is the 433. It's got the red dot. So these modules are not LoRa. They are like ISM band packet radios. That said, if you don't need LoRa, these are a lot cheaper because you're not paying the LoRa licensing fee, the complexity. They're great for if you want to send messages between different devices. There's an SPI protocol. There's library code for Arduino, for MicroPython, for CircuitPython. Again, the RFM series is super popular. It can do FSK, ASK. People also use these to listen in. You don't have to use them for transmission. They're great for listening because they're also transceivers. That said, whenever people are like, oh, I want to have, a board that senses data over here, send data to another board over there. I don't want to use Wi-Fi or Bluetooth. I just want like the packets to be sent. This has CRC management for you. So it does like, data correction and checking for you, packetization, addressing, all that good stuff. So the RFM 69 series comes in 2 frequency sets, 900 megahertz, 433. Use whatever is the ISM band in your area.
stop.
Next up, we've got 2 lenses for the Raspberry Pi 12 megapixel camera that we put in the shop a couple weeks ago. So that's the camera at the bottom, and those are the lenses. And there's 2 lenses. One is the telephoto lens, and one is the wide angle lens. So there's 2. This is, I think that's the wide angle. Actually, I don't remember which one is which. One is wide angle and one is a telephoto. And the narrow one is a telephoto and
That makes sense.
this one.
That looks
Just
like
a telephoto.
Yeah.
And the other one is wide. The wide is like 120 degree. The telephoto is, I think, 18 degree. It's very narrow, but it's great for far distances. So one is basically for close-up cats, and one is for far away cats, depending on what you're photographing. So let me.
That pretty much describes it.
That's pretty much it. Well, they're both, they're
Yeah.
both used for like, you want to take photos of something far away. Hold on, let me get this overhead a little closer, and I can show the lens. So the lens is screw on. So this is the wide. You can see it's got that lens, and it's going to distort stuff on the outer edges, right? But that's on purpose. It's wide angle. And then you focus it by screwing in and out. And then don't forget, this is a raw, like you can kind of barely see the, let's see if I can.
What are you trying to do?
I want to show the sensor. So there's a sensor inside. So you have to have the lens. This doesn't work without the lens on top. Otherwise, the sensor can get
Grab one of the
damaged.
slides too if you want to do the slides. If you want to try to jam the light down in there.
Okay.
Yeah, and then you can go that way.
Oh yeah, that worked.
Yeah.
So you can see there was a nice 12 megapixel. Ooh, there you go. The sensor inside, and then
Yeah, again.
whoa, too close. Too many pixels.
There
Okay,
you go.
you can back it up. So this is the wide angle, and then as we mentioned, there's also the telephoto lens, narrower but the same threading, and again, remove the protector, put it on, and then you can focus in and out by screwing it on, screwing it. That's why there's so many threads. So two lenses. They don't come with the camera, and the camera doesn't come with the lenses, so it's an added expense, but it really takes the camera up a notch, makes it a lot more usable for this wide angle, good for like security camera type footage, telephoto when you want to take photos of far away birds or cats.
Alrighty, next up to start the show, besides you, Lady Ada, our team, our customers, our community is these ATtinies.
Yay, ATtinies. We have two more breakouts for the ATtiny series. We already did the ATtiny 817, and this is the 816, and we also have the 1616, which looks very similar, except one says 816 on the back and the front, and one says 1616. These are a much smaller version of the ATtiny teeny megacore. Basically, they're very powerful chips, but they're very small and they're very simple, which is what I like about them. And we use them, for this. I basically designed these for my development because I'm making new Seesaw breakout boards now that chips are finally available again. And it turns out that in some cases I want a much smaller chip than the 7 series. I want the 6 series, which is a tinier QFN chip. These run 3 volts or 5 volts. They run with up to 20 megahertz internal clock. They're very easy to program because they use UPDI, which means you can use one resistor, a wire, and a USB serial converter of any kind of cable or breakout. Just connect the RxTX pins through the resistor and then wire to the UPDI pin to program them. We use the Spence Condi ATtiny teeny mega core that for Arduino to do development for it. This just is our little development board, breaks out all the pins. You get I2C. Like I said, one is 816, one is 1616. The 816 has a bunch of ADC. It even has an 8-bit DAC, lots of PWMs, lots of GPIOs, and has 8 kilobytes of flash, and I think 512 bytes of RAM, or 256 bytes of RAM. And the 1616, I remember, has 16 kilobytes of flash, and it has a whopping 2 kilobytes of SRAM. So there's some cases where you want the 1616. It depends on what is available in the market as well. Like right now, so I can get some of the one chip and some of the other. So there's cases where you want one or the other, and the pricing and the availability may vary, which is why I'm carrying both. And I'm using, again, as Seesaw development. It comes with Seesaw code on it, so you can use it as a GPIO expander. I've got a demo here like I just kind of put one together really fast. The 1616 has a lot of SRAM, which means what I've got here is uh, a Metro Mini, so at Mega 328, and it's connected through I2C. So this is power. Move the power pins down because they're just power. This is that ATtiny board, and I have the output of, whoa, it's close. The 0 pin is connected to the NeoPixel data, and then I have power coming from USB. And this is getting I2C commands telling it to set the NeoPixels that it then writes. So basically, it's acting an I2C to NeoPixel buffer. And then you can see here, it's driving these NeoPixels, and it's doing a little rainbow swirl very slowly because it's going over I2C. So remember, it's not going to be very fast, but you want to drive 30 NeoPixels is actually just fine. So this one is the 1616, and I just put coded to make it, it has 2K of SRAM instead of either the 256 or the 512 bytes that the 816 has. And so you can actually, drive, this is 300 pixels or something, or 200 pixels. It can buffer the memory for that, whereas the smaller one can't. But we're also going to be doing some, projects that do need a little bit more RAM storage, and so that's why I've got the 1616. The 816 will do the job for most Seesaw projects where you just want, I2C to GPIO or ADC. And then, of course, if you want, you can always reprogram it with the UPDI pin from within Arduino by using that USB serial converter with a 1 resistor. And then you can use that as a controller for sensing other I2C devices. It doesn't have to be like one where it can be the other. It's acting as an I2C peripheral, but it can act as an I2C controller. I mean, it's a 16K 8-bit microcontroller running at 20 megahertz. You can do quite a few projects with it. Doesn't have USB, but we do stick on a regulator, so you can run it at 3 volts. By default, it runs at whatever you power it with. One thing, again, I like about it is it runs 3 to 5 volts just fine. There's brownout detect. Internal oscillator can run at multiple different frequencies, and there's great Arduino support for it. And that's the new product.
That's new products. The lighting turned out really pretty on that.
It's quite nice.
Yeah, it's very good. All right, and that is new products. Okie dokie, don't forget, whatever you saw there, it's in stock. ATtiny's. We're going to do some top secret. I loaded up a bunch of questions. People have good questions, so
Okay.
you don't have to post them again. I got some, but feel free to post any new ones up in Discord while we're doing top secret. Let's go to the vault. Okie dokie, top secret this week. You sent this over to me to post up, and we did. What is this?
This is an ancient design. This is a can feather wing that I designed like easily. Brian designed it, or I designed it. I remember we both worked on this project many years ago. I was about to release it, and then chip shortage basically like killed availability for the MCP 2515, which is what's being used here. This chip is in so many products, it's not surprising. It basically got bought out instantly. So with the part available again, I'm able to build this board. So it's got a 3 to 5 volt mini boost converter, just a switch cap to give you that logic level. The crystal and matching capacitors, reset button, MCP 2515, and over here this is the MCP 2551, which sounds very similar, but this is the CAN transceiver PHY element, and this is the SPI to CAN converter. And then all the way to the left is an edge mount DE9, and then over here is a terminal block option. So you add it onto your feather, and over SPI you can use it to converse with CAN boards, because there's some chips that have built-in CAN PHYs and peripherals, but you have to usually spend a little bit more. And sometimes you're like, look, I want to just use like my RP2040, or I want to use my NRF 52840, which I don't believe has CAN on it.
think the green screen is good so you can show different parts
I
of
kind of like
the.
that. Yeah, I was like, oh, I can.
Yeah, I think we're gonna keep doing this because we're able to set up a screen here. Okay, cool. And then I got a top secret. We're gonna relaunch, I don't know. Adafruit chiptunes. The idea behind chiptunes is we have a microscope that can show really close-ups of electronic parts, and then we get cool bands that we know because there's blippy bleepy chiptune music, and we just play music and we look at the chips really close up. We had started to do this a long time ago, but then life happens, chip shortages happen, and more. And this is one we did. This is a close up of I think it was Circuit Playground um, when we first launched Circuit Playground. And what we did is we showed all the different ways you can zoom in and zoom out with at the state of the art at the time, how close you could get with kind of like live webcams and stuff like that. Things have progressed quite a bit. That's not so bad. You can kind of see.
Yeah, you just have to see parts, but well, like we again, this microscope has been in storage for quite a bit, but we cleaned up and we organized a lot of this area. If we can magnify even more, maybe. But it's a nice confocal microscope with tri-head, so you can have a
Yeah.
HDMI output, which is why you can get like really good looking images. It's not one of those like little mini desktop
Yeah.
microscopes. This is a nice microscope.
Yeah, and as someone mentioned here, chiptunes like journey into the microcosmos but with electronics. Yeah, it is. It is like that, and I think this is what one of the things for us too. It's important to do a lot of these things live because that's special. There's a billion channels. You can watch anything anytime, but live is special. We all get together, and of course you can watch it after. But I think that's one of the neat things about some of the shows that we do is you can participate and meet people and talk to people, and there's some interactive portions. So, anyways, we're gonna try to do it top secret, but coming soon. All right, we're gonna roll right into questions.
Okay.
So the first question, this is when we were showing some of the boards earlier. I saw the raw seesaw. Are there advantages for each chip, or is it to make it so there are many choices in the event of one or more going into stock?
It's basically it's a trade-off of price and availability. The 1616 is the one that has significantly more RAM. But there are pricing, although right now the pricing is a little bit weird because the market's still kind of getting out of shortage mode. But I basically I want to make sure that all the code that I write for these Seesaw boards runs on any of these chips. So I'm not stuck again with like, if I can't get this one chip, like, 20 products go out of stock. That was really rough. So, being able to swap between them would be valuable.
Yeah. It was tough the last few years going through the chip shortage, but I think one of the things is, you get through it, but then you're like, how can I make sure that doesn't happen again? So even though we probably overcompensated for like having a completely diverse supply chain, like, okay, we were never going to get stuck with just waiting for this one chip again. I think long term will be better because that means we can probably get better pricing sometimes. We don't have to wait when there's like some ecological or political disaster, or balloons are getting shot down and we're not friends with some countries for some reasons, some weeks. So, anyways, I think it'll be better long term. There's Basic on the Raspberry Pi. Pico is Python next.
I don't know about Basic.
Okay.
Sorry.
With all of the Qt Py BFS being created, will there be female headers? Is there a supplier that can produce them?
I would just use the right now I'd say use the itsy bitsy header set. I will eventually get a Qt Py header sets. I just haven't gotten around to it yet.
Okay.
But yes, they have to be custom made.
What are the dimensions of the ATtiny breakout boards?
It's like 1.5 by 0.6 maybe. I don't know. It's the ATtiny 1616. It's basically the same dimensions as the 816. I think it's the same dimensions, just has fewer pins.
Okay. Next up, I'm looking into creating boards for kits for the company I work for, and I want to make it open source. They allow what is involved in creating open source licensing for products, and how do I separate the open source nature of it with the protected part? Like Adafruit has the feather name, Adafruit logos and characters, are all those open source too? No. In fact, that's the cool part about doing open source is you can do open source and give away everything, but protect the thing. Like we just don't want someone to call someone Adafruit. So Adafruit's a registered trademark. So take our board, make the board, just don't put our logo and our name on it. There's special instances, and I think I owe someone an email. There's like the feather logo, and there's certain trademarks that we have where we just say, "Oh, you're doing it for open source. Here you go. Use it perpetual forever, with permission and all that." But what you want to make sure, and this is what happens with a lot of open sources, there's the open source project, and you want people to share the code, put it under a license. We use like MIT license a lot, but the name of it is the important thing because you don't want to have confusion. People could fork it, they could do things, but you don't want them to call it the same thing. Logos, that's something you can protect. There's the code that uses a license that's copyright, and then trademark happens to be, things like logos and such. If you come on Desk of Lady Ada on Sundays, hacker time, whenever that is, you can ask any of these questions. We don't do legal advice, of course, but schematics, we've done Creative Commons. But for the most part, we can answer these things.
I think also OSHWA has a great FAQ. Should
Yeah.
get the OSHWA.org FAQ.
Yeah. But that's the cool thing is like, especially I'm kind of surprised more companies don't do open source because I think they think that it's like, oh, like you're giving away everything. You're giving away the important things like the code, in our case, hardware and schematics, but you're not saying you get to be Adafruit. You're actually doing something I think that makes the most sense, which is, you can always reverse engineer hardware. You can always look at it. So why not just have a community and people contributing code and doing all the good things around that, but then still having your name is your name. Next question, what is the name of the screen that is used on the round rec TFT display that is in the store?
Check the data sheet, which we've posted in the tutorial for that display. I don't remember the part number for it.
Yep. Okay. Yeah, and then a couple people said, who will own the license in your organization? So that's one thing that's important, especially for open source projects. Make sure that the person or the entity is like, oh, we're making this license. Here's who's putting the license out there. Make sure there's some type of organization behind it. Sometimes in open source projects, no one gets around to registering the trademark. You have to eventually figure out someone to do that. But you could still say, here's who owns it and here's the licensing, but you have to determine someone has to take charge at some point. Next up, there was a question about what's the best way to parse small bits of XML and Circuit Python requests?
I think we've done XML. I think there's an XML parser that we have in CircuitPython.
Yeah.
To search for the learning system for XML and CircuitPython. I'm positive that it's not on the smaller boards, but on the larger, the ESP32SXs and friends. I believe there's a library for parsing XML.
And then
or there's a user library.
Mark suggested if you convert it to JSON, there's regular expressions that can help with that.
Well, JSON, we have a JSON parser, so you don't have to. I don't parse JSON by hand, and don't forget you can't really parse XML by hand either. But I believe that there's a basic XML tokenizer.
Okay. Question: is it possible for a company to make the same board, make a board with the same Wi-Fi module as a Pico W? Have you thought of doing that?
We've asked Raspberry Pi to release a module based on that chip because they get pricing that we can't compete with. Like basically, if you look at what the chip costs, it costs more than just getting a Pico W, right? So it doesn't make sense for us to buy the raw chip. So we've asked them to do the module, but don't forget, the module at this time uses Wi-Fi and Bluetooth libraries that are licensed only to be used with RP2040. So it's like if you're using it, you have to use it with RP2040 for you to be able to use that firmware without paying a license fee.
And then someone has a cool iSpy board. They said, hey, I put the logo there. Is it okay?
Yep, go for it.
Let's see. Best use of a desktop microscope is by a Twitch streamer called OpenSet. I'm going to check that out.
Okay.
Here's a pro tip. When dimensions aren't shown on board, count the header pins along the edge there. 1 inch. Oh, yeah, that's a good idea. Okay. Just a little bit more of a follow-up. The person's going to they're going to champion open source within their company because it could all still profit from the hardware sales, but the community can benefit from the resources they generate and benefit from the community input as well. So here's the thing, again, if it's open source hardware, most people aren't going to make the hardware. Like most people aren't going to be an Adafruit to make the hardware. We sell the hardware, But then when you release the code, instead of maybe in I'm not going to say waste, but maybe I'll instead of wasting all your money on developer relations and marketing, trying to convince people to use your thing and it being closed source, you make it open source and you build a community around it, and people want to participate and they want to do things. I mean, I think there's a combination of both. You still probably want to do some type of marketing in some cases, but good documentation and open source code is good advertising if you look at it that way. Let's see. I think that is almost it. Let me just
Okay.
make sure that I hit all the other chats. Couple of posts of orders. I said thank you for getting it out. And I think that is everything.
Okay.
That's our show. Thank you so much, everybody. That was Ask an Engineer this week. We very much appreciate the time that you spent with us. Special thanks to Zay, who's behind the scenes in the Adafruit Slack channel, helping customers, and more special thanks to our community, our customers, and I guess everybody making this thing work. Speaking of open source businesses, we're doing something a little different out there. No loans, no venture capital, woman-owned electronic company in New York City doing open source hardware, giving away all the designs. I can't believe you're doing that. But turns out that's a really good way to build a community and get hardware out there to the folks who want to build and learn and share. So we will see everybody next week.
Thanks, everybody.
Here is your moment of Zener.
Keep meowing.